Hey guys, in today's video I'm going to show you the easiest way to create a custom version of Miguel's professional firmware that will work on any 3D printer running a 4.2.2, 4.2.7, SKR Mini 3, and many others. But before we get started, guys, if you're new to the channel, consider subscribing, turn on your notification bell, and make sure to leave some comments. If you enjoy this video, give it a thumbs up. Alright, let's just jump right into it. In the video description, I'm going to link this file, and it's a PDF that was put together by my good friend Doug O'Connor. And this is what we're going to use to create our custom firmware. So go ahead and open up the document, and you're going to come across step 1. It's going to tell you to go to this link. So let's click on it. And what we want to do here is we want to download the source zip file. Click on this little green box, download zip. Once you have it on your in your computer, go ahead and unzip it. I'm going to extract it to the desktop. All right, once that's done, let's go back to the document. It tells us to unzip it all and give it a name. Open the folder and let's look for configurator.pyw. So from our desktop, let's open up our special folder. Scroll down and look for the configurator.pyw file. And now, before you use this, you have to make sure that you install Python version 3 dot whatever the current version is. And in the document, I added some links to it. So you got a link here for Python. If you click on the link and allow it, it'll download the Python program to your computer. You're also going to need Visual Studio Code. If you click on this link, it'll take you to the Visual Studio website. Select the version appropriate for your computer. Lastly, you're going to need PIO. Click on that, allow, and you're going to download the version for your computer. I believe it's available for Windows. Yeah. I'm not sure if this will work on Linux, guys, but it does work on Windows. All right, so let's go back to the desktop. And in the configuration folder, let's open up configurator.pyw. Double click it, and you're going to get this dialog box here. Now, this box has some predefined printers. So if yours is already predefined here, just go ahead and select it. In my case, I was working with a custom version for a CR10S Pro V2 that's running a 4.2.7 board. So for me, these configurations are going to work, but you can leave the any one of these choices is okay. So I just left the default Ender 3 V2 choice, but I changed the default board from 4.2.2 to 4.27. And then you also want to designate which display you're running. For the Ender 3 V2, which is the display that I'm using on my CR10S Pro V2, I selected the DWin. So select that. If you're using a BL Touch or CR Touch, select BLT. If you're using EasyABL or any other, select that. MM is for manual. And also check UBL if you're interested in unified bed leveling. Your thermistor type, T1 is the default for the Ender 3 V2 and many other Creality printers. But if you have an upgraded thermistor, make sure to select the appropriate one. Under the Features tab, here you can select the different options that you would want. So for me, I want the home offsets, I want input shaping, linear advance, and MPC. Click on Set Config, and then click on Generate. Okay, it's going to say configuration files generated, and the default name that it's going to give it is My Configuration. You can change this to whatever you want. So I'm just going to leave the default, click OK. And I'm going to go over here. And if you notice now, I have a My Configurations folder. So what you want to do with this thing is double click it. And you want to highlight Configuration H, Configuration Advanced H, and Platform IO.ini. You want to right click on these, copy, and then let's minimize this for now. So now let's go back to the document. Next step is going to be to go to this next link. So this is the repository that keeps the current version of the firmware. So let's click on this link. Again, same as before, click on the green code button and click download zip. So once it's done, click on show in folder. Let's right click to extract it, extract all, and I'm going to extract it to the desktop. And this may take a couple minutes. All right, once it's done extracting, go ahead and open the folder. And you want to double click in the Marlin folder. And in here, you're going to right click and you're going to paste those 3 files that we copied from the special configurations folder. It's going to prompt you, select replace the files in the destination directory. All right, so now we can close these. And next thing we want to do is open up Visual Studio. From here, click File, Open Folder, navigate to the location that you unzip the folder to. In this case, it's on the desktop for me. Open the folder, and this is the main folder, the one that had the last file that we downloaded, not the special configurations one. Once you have the folder selected, click Select Folder, and then give Visual Studio a couple minutes to load up. All right, once it's all loaded, we're going to navigate over to the Marlin folder. So just click on this little drop down and then select Configuration H. And this is the area where we're going to make any edits that we need to make to the firmware prior to compiling it. And I'll include also in the video description this quick little cheat sheet that I used. So all I have here is just a couple of things that I searched for in this document to make certain changes. Something that you may want to change is the custom machine name. So just copy the first line, click on the in the body here of the document, and press Control F. That's going to open up this little search box, and in here you're going to paste that first line. Make sure you don't have any spaces, and then it's going to take you to that particular area. And here you can call this whatever you want. So you can change this name in between the quotes to, let's say, CR10S Pro V2 Custom. Next thing you'd want to change is probably the thermistor type if you've changed yours from the default one. So again, select the next thing, highlight in here, paste it, and then we got this area here on analog thermistors. Now this list is important because if you have something other than the default thermistor, it will be listed here. So for example, if you're using, let's say this 200 kilo ohm Copy Master 3D, you would use this number 202. And let me show you where you would put that in. So you scroll down here to where it talks about the temperature sensor. And right now it's got number 1, which is the default temperature sensor, but you can put in here 202, and then that would use the values for that particular thermistor. In this case, we haven't changed anything, so we're going to leave that value default. Next thing you'd want to do is, if you want to change the max hot end temperature, let's say you want to upgrade later on to a all metal hot end, or you've already upgraded, you can go ahead and change that value. So just paste that into your search box. You're going to be presented with these choices here. And the one you're looking for here is heater max temp. And by default, it's 275. But this has a 15-degree overshoot. So if you notice down here where it says hot end overshoot, it has this number 15, which means that the max temperature is going to be 260. So if you want a max temperature of, let's say, 300, you would need to change this number to 315. So 315 minus this overshoot of 15 is going to give you a max temperature of 300. Same thing for the bed. So if you look here, there's a bed overshoot of 10 degrees. Our max temperature here for the bed is 120. So if we want a maximum bed temperature of, let's say, 130, we would need to change this to 140. All right, let's go to the next one. It would be mechanical settings. So I'm going to right click, copy, paste it in here. And then we get to all the mechanical settings. Now, if you were running something different than a Cartesian style printer, let's say you want to install this 4.2.7 board on a Core XY printer, you would have to uncomment these lines here. So you just find the appropriate one. Let's say it's a Core XY. You would uncomment those two lines there. And then that would change this to work on a Core XY printer. In this case, we're not going to make that change, so I'm just going to go ahead and put those comments back in there. Let's get the next one. And paste it. And in this area here, we're going to determine the maximum size of the build plate. So in the case of the CR10S Pro V2, we're going to change this X to 310. Y is going to be 320. And then this next section below it, where it talks about the Z max. So these would be the maximum travel for each of these axes. So with the modifications that we made to the CR10S Pro V2, if you guys followed along the last video, our max X position now is 345. Our max Y is 320. And max Z is 420. Okay, let's grab the last one. Paste it. And in this area, you can customize the values on these pre-built filament types. So for example, if you do a lot of PLA printing and you happen to print at 190, you would change this value to 190. Bed temperature, if you're using a heated chamber, you would change that temperature or that value to the max or the minimum or whatever it needs to be. If you print with ABS, you do the same. In my case, I don't use ABS, but I do print with PETG. And these values for PETG are on the money. Another one that I like to use is nylon. Typically, this one is named custom, but I have already been in this config.h file, and I changed it to nylon, bed temperature of 0, hot end temperature of 230, and no parts cooling. And that's pretty much everything that I changed. Now, there's a lot of settings in here, and you can scroll down through this list. But just be careful if you are going to change something here. Make sure that you keep some kind of a log of what you're changing. In case you run into an issue, you can go back and correct the problem. Now, in the event that you jack up your configuration H file and you just want to start over from scratch, what you can do is click on File, or if you've opened recent folders, what will happen is Visual Studio will continue to load a file even though it has an error. So to clear that error, you would go over here to where it says Open Recent, scroll down to where it says Clear Recently Opened, click that button, and then it's like you're starting from scratch. You have to select the folder you're going to open, and so long as you didn't save that configuration H file, it'll open the original folder. All right, so we're good to go. We're ready to compile. So what we're going to do next is click over here to where it says Auto Build Marlin. And if you're running a 4.2.7, the first choice would be the one that you use, which is this build. If you're using a 4.2.2 board, which is the stock board on an Ender 3 V2, you would select this first one down here that says STM32F103RC Creality 256. That's the one that applies to the 4.2.2 board that comes stock on the Ender 3 V2, Ender 3 Pro, and Ender 3 Max Neo, and Ender 3 Max. So those are the stock boards for those printers. In this case, we're going to compile for a 4.2.7 board, which is the one that we have selected here based on the selections that we made in the configurator file. So make sure that if you selected a 4.2.7 in the configurator file, that you use this first Marlin firmware build, auto build choice. So I'm going to go ahead and click it. And this will take a few minutes. All right, once it's complete, you're going to get this done. And if it worked properly, you can come up here to PIO, click on the little drop down, select this STM32F103RE Creality, and then your firmware will be right here. So at this point, what you can do is you can right click on this, and you can reveal in File Explorer, which is what I like to do. And then if you notice, it's got the timestamp. So just look at the clock on your computer. It should match very close to this time. This is the bin file that we just created. What you want to do with this now is put this on your SD card. Turn off your printer. Turn your printer back on. Give it a few minutes, and it'll flash this firmware to your printer. If you're running an Ender 3 V2 display, you're going to need to flash the display. To do that, you can go back to the root folder here. So this is that root folder that you unzip to your desktop. You can scroll down to where it says Display Assets, double click it, and the one that you're interested in is this. So you're going to select this second one here, this compilation folder. Double click it, and in here you got a DWIN set. So you're going to right click this entire folder exactly the way it is, copy it, and you're going to paste it onto an SD card. So I think I got an SD card in here loaded on in my computer here, so I'm going to just go to it. So what you're going to do is you're going to right click and just paste it on your SD card. And then you're going to place this SD card inside of the display. So if you take the display apart, there's going to be a slot for an SD card. Put the SD card in there, plug the display back to the printer, make sure the printer is off before you unplug the display and take it apart, and then turn the printer back on. The screen will go blue, and then it'll go like red when it's done flashing. That's when you know it's complete. If you click in this folder, you're gonna see it's got some funky bin file in here and some JPEGs. That's normal. That's what's supposed to be in there. And that's pretty much it. I'll link a video on going through the flashing process. That way you guys can follow that video. I don't want to make this video too long. Alright guys, I just wanted to show you what I've been working on for the last couple of weeks. A few of you have asked me if I was going to make a version of the minimalist fan bracket for the Micro Swiss NG, and the answer is yes, because the cooling solution for the stock fan assembly is inadequate for doing a good enough job to cool the parts effectively. So what I got here is a version that I made up. I downloaded a CAD model from GrabCAD of the Micro Swiss NG, and then just built all the components around it. What it utilizes is two 4010 blower fans and one 30mm fan that you can get from E3 V3 hot end. So if you go over to the E3D store, or even Amazon might have something like this, it's a 30mm 24-volt fan. So that's what's gonna be used for the heatsink. And then you got the 4010s, they're on the side. So this gives you a true dual cooling solution, independent fans. That way you're not trying to share inadequate airflow between two ducts. Each one has its own short duct assembly. And anyway, and I'll keep modifying this to get it perfect. I think the fan placement is as good as it's going to get, but I may be able to spend some more time playing around with the duct angle to get it just perfect. I'm currently doing some testing right now, and I'll show you in a second the prototype that's on the printer. But if you guys are interested in this, let me know in the comments. If you are, I'll upload a version to my Shopify store and make it available for purchase. If you guys want to support the channel, that would be great. So let's head over to the printer and I'll show you the physical version. Alright guys, if you're new to the channel, consider subscribing, turn on your notification bell, and leave me some comments. I love reading the comments and do my best to get back to you guys as soon as I see them. If you enjoyed this video, give it a thumbs up. Until the next one, take care.